There are times that you want to have control over an attribute in a class. For example, here we have this product class. In the constructor, we set the price attribute. With this implementation, we can create a product object and give it a negative price. And Python interpreter will execute this without any problems. This is not good. So how can we prevent this? How can we ensure that our products don't have a negative price? Here's one simple solution. We can make this field private and then define two methods for getting and setting the value of this attribute. So we define a method called get_price. Here we simply return self.price. And similarly, we define set_price that takes a value. Now here, first we check if value is less than 0, we can raise an exception of type value error, saying price cannot be negative. Otherwise, we set self.price to this new value. Now, in another implementation, instead of raising this exception, we could just ignore setting the value if it's negative. Now, with these two methods in place, we go back to our constructor. Instead of directly setting the price attribute, we call self.setPrice and give it this initial value. When we run this program, our data validation logic is going to kick in and it will throw an exception. Take a look. So we got a value error because price cannot be negative. So this was a simple solution, but it's kind of ugly. It's what we consider unPythonic. Pythonic is one of those expressions that you hear a lot in the Python community. When we say this code or this implementation is not Pythonic, that means it's not using Python's best practices. It's not using the Python language features to the fullest potential. This implementation is the kind of code that a Java programmer learning Python writes. But in Python, we have a better way to achieve the same result. That's when we use a property. A property is an object that sits in front of an attribute and allows us to get or set the value of that attribute. Let me show you how to define a property here. So, in our product class, after we define these two methods, we define a class attribute with the ideal name. In that case, we want to call that price. Here we call the built-in property function. This function takes 4 parameters, and all these parameters are optional. The first parameter is a function for getting the value of an attribute. The second parameter is a function for setting the value of that attribute. The third parameter is a function for deleting that attribute. And the last parameter is for documentation. In this case, we need to supply 2 arguments. The first one is going to be getPrice, and the second is going to be setPrice. Note that I'm not calling these methods. I'm simply passing a reference to them. So when we call the built-in property function, with these arguments, this function will return a property object. That property object will use this function for reading the value of the price attribute. Now, by adding this line, we can come back to our product. Let's set the initial price to 10. Here, when we use the dot operator, you can see we have this price property, and we can use it like a regular field. So we can simply print it here, and we see 10 on the terminal. And also, we can set it, but if we set it to a negative value, this will throw an exception. Let's run our program. There you go, value error. So a property looks like a regular attribute from the outside, but internally it has 2 methods that we call a getter and a setter. Now, while this price property solved our problem, the 2 methods that we wrote are still accessible. So if we type product dot, you can see we have getPrice and setPrice methods. These methods are polluting the interface of our object. As a metaphor, think of a remote control with 50 buttons. Nobody likes that kind of remote control. It's so confusing. It's much better to have a remote control with few buttons that can do a lot. We want our objects or our classes to be the same. We want them to have minimal number of functions or methods exposed to the outside. So, to hide these, one solution is to come back and make them private. But again, this adds extra noise in our code. There is a better, shorter, and cleaner way to achieve the same result. We can use a decorator. Remember decorators? Earlier we used a decorator called class method to convert an instance method to a class method. We have another decorator for creating a property. So instead of explicitly calling the property function to create a property object, we can apply the property decorator to this method. Then we rename this method to the ideal name. In this case, we want to call it price. When Python interpreter sees this code, it will automatically create a property object called price. Now, similarly, we need to apply another decorator to this method. The name of that decorator starts with the name of our property, in this case, price, and then dot setter. Also, similarly, we need to rename this method to price. So our implementation is cleaner, it's less noisy, we don't have that get underline and set underline. This is much better. Now, how this works internally is a little bit complicated, and we're going to look at that later in the future. For now, all you need to take away is that with these two decorators, we can easily create a property. Now, there is one more place that we need to modify here, and that is our constructor, because we no longer have set price. But the good thing is that we can use our price property like a regular attribute. So we set self.price to price. With this new implementation, if we try to create a product with a negative price, our code will throw an exception. Let's take a look. There you go, value error. Now, one last thing before I finish this lecture. When defining properties, you don't always have to define a getter and a setter. In this case, if we comment out these few lines, we'll have a read-only property, so we can only read the value of this price. Once we set it, we cannot change it. So we can initially set it to, let's say 10, but if we try to update it later, we'll get an exception. So if we set product.price to 2 and run this program, we get an attribute error because we can't set that attribute. So this is all about properties.